So hello everyone. So I'll be talking on healthcare standards and secured medical devices. So first of all, before I begin my session, how many of you have worked in healthcare industry? 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty good. And how many have you actually pen tested the systems, hospital systems? You two keep your hands down. So these two are from my company. So yeah. Anybody has worked on HL7, DICOM? No? Okay. Never mind. So yeah, let's begin. So a small disclaimer. This presentation does not reflect any opinions of my employer, and everything belongs to me. All demos, all data, everything. So who am I? Product security engineer at Philips Healthcare. So I am having interest in breaking medical devices. Apart from that, I do some crazy things that nobody likes. So I will be not talking about those things. Yeah. So today's agenda would be healthcare security, healthcare standards. We'll be covering HL7 2.x, FHIR, DICOM. Then we'll be talking about something about the hardened systems and how to pen test those. And then at last we'll conclude our presentation with the how to secure the HL7 standards and the medical devices. Yeah. So first question that I would like to ask you all, what do you understand by healthcare security? Any answers, any layman answers? Yeah. Data privacy, yes. One more thing, yeah. Yes.
If that goes off, then someone might die.
Yes. Anyone? So I think this lady covers one part and the guy over there covers another part. So mainly healthcare security covers a lot of aspects, but I would mainly focus on two aspects, that is data security and the device security. So data security, as you know, that PII healthcare data is very important and it's very critical. Now I have one more question for you. Why healthcare data is very critical? If I compare with the data of healthcare industry with the data of financial, like credit card and debit cards, can anybody tell me why healthcare data is more important?
First thing, there are a lot of diseases which people don't want to be known outside if they have
Yes.
something. Second thing is, okay, it's healthcare data. It tells everything about them, right? So that I don't know how have the perfect words right now, but if it has some modification or something else, right?
Yes.
It might cause a lot of issues. So I've read a bit of HIPAA, so I know these. But
Okay, so it's
thank
the
you.
compliance that works in US. Yeah.
Just as an add-on, for example, if a person is suffering from an allergy and that thing comes out, a health threat could occur from his enemy. So similar sort of incident
Yes.
may require the protection for the healthcare data.
Yeah, so it's about the confidentiality that every patient wants to keep their disease to themselves only. So yeah, so this is one aspect. Another aspect that I would like to convey to you is the healthcare data is a permanent data. Your name is a permanent thing. Some fraud has happened with your credit card, you can block it. With your debit card, you can block it. If your money is lost, you can gain it back. But the data in healthcare industry is moreover a permanent data. Like if I'll show you some information that the medical devices and that they have. It's like SSN number. You cannot change this. You cannot change SSN number easily. Second thing is your address, your name, your gender. These things are the permanent information. Once stolen, you cannot change it. And if you want to change it, then there is a lot of trouble, like SSN or Aadhaar card number. I don't know. Have anybody changes the Aadhaar card number and all? No? Yeah. Yeah. So this guy has changed his name, that I know. Yeah. So why is it so important? The answer I just gave it to you. So because the data is permanent, and once lost, it is hard to change it, and yeah. It is hard to think. Yeah.
You said healthcare data is important, like when it's your PII, like address
Yeah.
and stuff, right?
Yes.
So tell me, like, if I had a disease or something like malaria,
Yes.
and what's the risk actually? I know that people don't want things to be known, but
Yes.
if it's available to the public,
Yes.
so what's gone? Because biometrics, I understand, really, but
Yes.
like if your blood group is exposed,
Yes.
why is
So,
risky?
so it depends person to person. So, if you are any Bollywood celebrity like Amitabh Bachchan and all, then definitely that would matter. That will. So, if they have the disease and that gets leaked, it's a TRP information. It will be news all over places and all. Nobody cares if I have malaria and all. They will say, okay, get lost, go away. Yeah.
Time when you're unconscious, you are actually based on your medical information. Not happens in India much, but it happens in a abroad. That based on your history, you will be given the blood, or you will be treated accordingly. If I have a chance to manipulate the history or write something else there, they will not even think, and they will give you something which may not be good for you. So think from that perspective that it's your information, you have a full right on it, nobody else.
Yeah, it is the second part. It is the second part that if you see in India, it doesn't matter much, but if you see in abroad, the prescription of the medicines is based on your diseases. So you cannot take any medicine like that only. It has to be prescribed by your doctor. So if you get hold on to some information that has some disease through which you can get some drug, which is how would I say, which is useful for your dreams or something. So those kind of drugs you can take it by having this fake medical bills, or if you get to know that this person is having this disease, so you can easily it's like you can change the content of your prescription according to that guy, and you can get drugs easily. So this is one more aspect. Yeah. Yeah. Sure. So it is not working. It stopped working. Yeah. So few terms before we go ahead. EMR, electronic medical records, is a digital form of medical data. RIS, radiology information system. It is the system that contains the information about the radiology department. PACS is an archive system for the imaging modalities like CT scan, MR, ultrasound and all. HL7 is a healthcare standard that we'll be talking about. FHIR is the most advanced HL7 standard that again we will talking about this one. And DICOM. This is the standard for imaging modalities or imaging medicines like CT, MR, ultrasound and all. Yeah. So before I go into each standard, this is one of the simple, the workflow in hospital, how this standard works. So suppose a patient comes to the hospital, he goes to the registration desk. Whenever these entries are fulfilled, the first message that will be created by the system would be the HL7 ADT message. So ADT is admission, discharge, transfer message. We will be talking about ADT message in more detail in coming slides. So this diagram is just to give you the overview how some of the standards and how all the modalities are connected to each other. Yes. So after that, based on the patient information, patient might come and say, I am having chest pain or I am having this kind of problem. According to that, the registration desk will transfer the ADT message, suppose say to some doctor. Now doctor, based on the I am having a chest pain or something, okay, let's have some CT scan or ultrasound. Based on then he will create one HL7 ORM message, order message, which will go to the RIS system. I have kept it RIS system here because it is dealing with the imaging system like CT, MR. So imaging is X-ray, MR, like everybody knows, right? So they create one image, and so those kind of modalities are called imaging. So when I say modalities, modalities are like your machines, CT machine, MR machine. So if I say modalities, don't get confused with those. So once it goes to the RIS, from there, the technician or nurse you would have seen in the hospitals, when you go for a X-ray, there is one technician who will come to you, take you to the machine, and will take your X-ray. So that is the modality CT X-ray technician who will take the your let's say any X-ray, and that X-ray image will go to the PACS server using the DICOM. So DICOM again is a standard for imaging, as I said to you earlier, that I will be discussing in more details, and we show some demos of DICOM as well. After that, these EMR doctors and PAC clients radiologist is like just, so if I talk about PACS clients radiologist, so once you have an X-ray, you give some information like, okay, this in his lungs, it has certain kind of this percentage of disease or this thing. So these are done by this OBX reporting. And after that, if doctor wants to see that that image or the information about the patient, then he will use the web service patient query and takes the data from PAC server directly. So this web service patient query generally doesn't provide privilege to doctor to edit anything. It's just to see moreover. So it is just a basic diagram to let you understand how the HL7 and DICOM flows in the hospital. So yeah, so before I go ahead, let me tell you why HL7 came into the picture. So before, when the manufacturer of the medical devices, they were they were building devices, many devices. So hospital buys one device from one vendor. Now another vendor makes some device that is more advanced, and they want to integrate with their current one. But the problem was initially the language problem. The language that suppose one company, the device of one company understand, will not be the same for another company's device. So this is called the interoperability problem. So to rescue from this problem, HL7 came into the picture, and they said, okay, let me create one common language that will be understandable by every device, and you need to follow it. So after that, HL7 standard came into the picture. So HL7 and its member provides a framework for the exchange, integration, sharing, retrieval of electronic health information. The version 2.x is I think it is the initial one, which as it says, an interoperability specification for health and medical transaction. FHIR is the most recent one. It has other standards also like 3.x, CDA, CCD, SPL, but the main focus of this presentation would be on HL7, 2.x and FHIR. So HL7, this is the definition of HL7 from the hl7.org itself. So HL7 is the most widely used standard in the healthcare industry. In more than 35 countries, it has been implemented. In US, 95% of the US organization uses HL7 2.x, and it is still being used. Even the product that are being manufactured right now, because they are moving towards the FHIR, but still they have to support HL7 2.x. So it is the most widely used standard. So these are the delimiters that HL7 2.x uses. So I just kept this slide here so that when I go ahead to the next slide, and I will show you the message so that you will be able to understand. So these are the parameters. Like first one is pipe. It differentiates from one parameter to another, like name, age, sex, gender, these kind of things. And this caret, relay, backslash. So I will be explaining these in the next slide, coming slides. So this is how the HL7 2.x message look like. So one row in a yellow color is like a one segment. Every HL7 message has first message header, that is MSH. So if you see the slide, the first row that calls MSH is the message header information, that from where it generated, where it is going, for what purpose it is. Now the second row, if you will see, the second segment I would say, contains the patient information. Its email ID, its name, its address, where it lives. Now that is why the HL7 messages are more important, because it contains the PII. And in hospitals, if anybody has done pen testing in hospitals or hospital-alike environment, you would see these are the most common messages that will flow everywhere. You just sit somewhere, and if you capture, through Wireshark or TCV dump, you will be able to see a lot of messages containing patient information, and they will be traveling like, and the amount of data that is being generated by this system, it will be very huge. It might be possible that your, packet capturing tool will crash very fast. Now the next information that is contained in next of kin information, that is NK1. If it is PID, that is patient information. And PV1 is the patient visit. Why it is important for a doctor and for an attacker as well? Because it contains the information if the patient has visited earlier. It gives the information, okay, for what purpose the patient has visited, what was the problem, and what was done for him. So that is why it is very important, and it is a plain text. If you see this message, it's a plain text message. So I will show you one demo also, because there you will be able to understand that how to manipulate these messages and what could be done. So again, HL7 2.x messages types like ADT. ADT is the most used message in the hospitals. So I will be showing some more ADT message as well in the next slide. ORM is the next message, like order, as I showed you into the workflow. ORU message. In the same way, there are many messages that HL7 2.x supports for different purposes. So as I said, ADT, admission, discharge, transfer, it is the most widely used HL7 2.x message in the hospital. There are about 51 different type of only ADT messages. So you can imagine there are multiple HL7 2.x messages, and the ADT itself contains 51 different type of messages. So ADT generally travels everywhere. If a patient comes, then there is a ADT. If it has to be transferred, there is a ADT. If it has to be discharged, there is a ADT. If you are making some modification in the patient report, there is ADT. So ADT is everywhere. And why ADT is important? In the previous slide, as I showed to you, it contains the information of the patient, personal information. So PII is the main thing about the, main concern about the medical. So yeah, so HL7 2.x attacks. So you can, if you are in a hospital and you get a chance to be in the network, you can simply do the Nmap scan based on the default ports. You can find it out. Some of the, again, all the things in the presentation that I'll covering is based on the implementation. So as HL7 is a standard, they say you have to implement like this, you have to implement like this, but based on the environment, based on the hospital to hospital, it varies. So there are multiple ways they can implement these standards, but again, based on the requirement it is. Second attack is the MITM plain text, as you might everybody would be knowing. Implementing a certificate inside the hospital is a costly thing. So this thing is very common in every hospital. If you are in India, I don't believe there is hardly one or two. Otherwise, there is any hospital who implements certificate-based authentication or authorization. Data modification. Now, if you are in a hospital and you can see the data, then based on the attacks like RP spoofing and all, you can modify the data and send it to the another server. Now, why I have said data modification and more radiation exposure to patient? So the machines like CT and MR, they create the radiation while they take the X-ray. So I think you would be knowing, right? So X-ray and all, they release some radiation which is harmful radiation, and the patient gets exposure to that. Now, if the data is wrong or something happened to the data, the patient has to come again for the X-ray, and again there is exposure to the radiation. So it does not relate anything to the attack, but it is very important for a patient safety. So as I said earlier, medical device security also is not about the data only. It is about the patient health as well. So in the initial slide, when I was telling you that I will be covering data security and the device security. So device is like you have a pacemaker device or pacemaker inside the heart. It is transferring data to some mobile application using Bluetooth technology and all. Suppose what happens if you perform some DOS attack on that Bluetooth device and it stops working. And if what happens if the patient is in the, he's on the ventilator. So ventilator supports multiple wireless technologies like Bluetooth because of the advancement in the medical industry. So these kind of wireless technology are being supported in these devices. And what happens if the patient is on the ventilator and you perform any attack and the ventilator shuts down? So it's like a death of the patient. So it only covers the data security and all. Though data security is very important, but life cannot be compared with the data, right? Or some of the people compare data is more important than life. Yes. So again, DOS bad server attack is like, so whenever, again, based on the implementation, whenever a HL7 message, goes to the server or to another machine, it waits for the response. So if it gets the response, it sends another machine. So again, HL7 interfaces has some limitations on the connections as well. Suppose one HL7 interface or the machine supports 10 connections only. If you somehow you get to know the machine name and you have 10 connections on the system, the legitimate machine will not be able to connect it. So this DOS will cover two kind of scenarios. One is that just I explained you that based on the acknowledgement. Second one is based on the connections. Now the client side attack in the sense, this HL7 message, as I have just showed you, this one is a text based, it's a simple. So if you put anything, it will be based on in where are you seeing the data. That is more important. Like now FHIR comes in. So I'll be talking more about FHIR in the coming slides, but FHIR mainly based on browser. It shows you the data in browser, and because the legacy system still supports HL 2.x, they are being migrated to the FHIR, but there is a broker in between. So you enter the message in HL7 2.x, then it is being translated to FHIR, then it goes. Now client side attack is, it's like you have put some data in the text field and it gets rendered to the browser. That time is scary. Let me show you one demo. So I think you'll be able to understand more. So I have used some open source tools because I'm not allowed to show any demo on the live environment that I have in my company because it discloses some policy and related things. So I have made some demo based on the open source tools. So this is one tool, Smart HL7, that sometime I use for my demo purposes. So I think it's not open source. It is licensed also. I'm not sure. So let me just. So left hand side I have HL7 sender, right hand side I am having HL7 message receiver. You just copy paste the data. Yeah. So this is the HL7 demo data. All the information inside it is a fake data, demo data, nothing personal information about patient. So why I'm saying this? Because most of the medical industry buy patient data for their, making the products or for checking their product working, whether it is working or not. So this one particularly, I have this demo data simple. So you just start the server here on port 1234. Okay. Yeah. So it's running now, listening on port 1234, and you just send the data. Timeout, waiting for, so see, waiting for acknowledgement. This is the one thing that I was talking about, but my demo is not working here. That's perfect. Let me try one more time. So actually in my laptop it was working, but my laptop was not working with these cables, projector cables, so I had to change it. Sorry for this. Let's try one more time. Okay, so it's not working. Maybe it's another laptop or some configurations are not set. Yeah, file I just copy pasted that, so there is no problem with the file. It's a timeout problem. It is not able to reach there. Firewall. Yeah, I allowed that one. Yeah. So okay, no problem. So I just wanted to show you over here is when you say any data here like Foster City, this is a personal MSS message and PID. If you edit anything over here, like you put any script or anything, it will directly go over there. There is no check. Now, it is only a text-based, so you will be saying that it is a text-based, nothing will happen. But again, it depends where the message is being rendered. So suppose there is a mediator in between that is, translating the message from HL7 2.x to FHIR. In those cases, it is very harmful because in here you can put anything, and if it goes in a particular field that is not being sanitized, it can perform any client-side attack. Is 1234 is yeah, let me check that again. It's 1234. Never mind, no problem. It was just a simple demo, so that's fine. So I was just from that demo, I was just the message that I wanted to convey you that because this is HL7 text-based data, you can put anything, and based on the data where it is being rendered, the attack might be performed. So it's loading. Okay. This presentation only. Will it work? Or whose laptop is this? Yeah, it works. So these are the HL7 2-point attacks that you could perform as a pen tester and find out the bugs in the hospital or in the systems. Yeah. So FHIR is the more advanced version of HL7 standards. It is the latest version, and it makes use of web and exchange data in XML and JSON format. So now anything comes to the JSON and XML, every pen tester's ears would be like this, right? So when it comes to the XML and JSON, that means the HL7 standard is more vulnerable to the attacks because it becomes like normal web application. So all the data that is being shared it also solves the problem of interoperability, but it also exposes itself for the known attacks that are already in the market. It is the latest HL7 standard. So this is how the HL7, FHIR message looks like. So if you want to see how a message, how a request message and response message looks like, you can go to these two links below that I have just said. And in this one, I have highlighted two IDs, that is bundle ID and the normal logical ID. So in FHIR, the main implementation which I have observed they have done is, instead of the segment, so if you go back to this slide, you see that every row is a segment, right? So every segment they have divided into the logical IDs, logical values, the second highlighted one. So every message has the bundle ID, that is the upper ID, which you can see in the image. The second one is the logical ID. So if you want to retrieve any data, so the one problem that FHIR solves is, initially if you want to make any modification in the HL7 data, so you have to, when you call the patient data, all the messages used to come together. Though you want to make changes in the PID, in the patient information, like, okay, address has changed. But if you want to make changes in the one segment, all the segment used to come together, like next NK1, patient visit and all. So the one problem FHIR solves, if you want to make changes is one part, so the logical ID will be called and you will have that response, you make changes and it will get stored. So that is why logical ID is very important. And again, based on the implementation, you might have logical ID which is small in length. As the data is being retrieved based on the logical ID, sometime if the proper implementation is not done, you can brute force this one, though it is a bit hypothetical, but again, as it is implementation based, it could be done. So attacks, as I have said to you, it is web based, so all the web based attacks are applicable, like JSON, XML, XSS, SQL injection. For pen tester, it is very easy. And sometimes when I see the guys doing the medical device pen testing, initially they had to do a lot of work in understanding the HL7 2.x message and all. But in FHIR, they have to work little less because it is based on web standards and it makes use of XML and JSON. Violating access control. This is the most, focused area for any pen tester. Why? Because in a hospital, one application will be shared among multiple users. Technician will be using the same application for one purpose. Nurse would be using the same application for another purpose. Now the doctor might having some right permission in the fields that only technician can see and observe the thing. So one application might be used for different user roles. Some of the data should not be seen by another user. So whenever, this is very important for pen testers, whenever you are doing any pen testing of a medical application, focus on the access control, and I bet you will find the vulnerability somewhere. Again, brute forcing, it was based on the logical ID that I said to you. Yep. Now, HL7 standards, HL7 2.x and FHIR I have covered. Now, next moves to the DICOM. So, digital imaging and communication is medicine. This standard is being used for the imaging devices like CT, MR, ultrasound. So, this is particularly for that domain. And it solves the problem of interoperability, definitely. And because the same data, if you see the CT image and the MR image, the viewer of every modality is different. Though I am saying DICOM, that is the imaging modality. But if you want to view any data for particular modality, the viewers for every modality is different. It's not like you have one viewer and you can you can see all kind of modality imaging in the one viewer. So yes, so this is yeah. So DICOM is used in imaging devices like CT, X-ray. Files, DICOM files is with the extension .dcm. If you search on the internet, you will find a lot. Modalities needs to be pre-configured based on the type of query. So DICOM does a lot of make use of queries that I will be showing you in the next slide with server, client IP address, port number, AE title. I will also see why these are important. AE title. It's a application entity title. I will be telling what it is. So how you have one modality in the image, you can see modality is like CTMR any machine. It makes use of DICOM networking protocol and sends the information to the PAC server. So PAC server is the picture archiving server. So whenever you have any CTMR images, it will directly go to the PAC servers. Now this is how a DICOM, one of the DICOM file look like. Now again, why I am talking about DICOM? Because again, it contains the patient information, personal information, PII. If you can see at the right hand side here, it contains the name of the patient and the gender of the patient. Here also it contains the name. This is one viewer that I am showing to you based on different type of modality images that they create. Different type of viewer shows you more information. But there are some information that every DICOM image contains, like one of them is the name. So there again, based on the standards, they have to fill in some of the information that is the personal information of the patient. That is why again, it is very eye-catchy for an attacker. So all the till now I have discussed about HL7, 2.x, FHIR, and DICOM. All contains patient personal information. That is why they are very important. Now DICOM message exchange. So whenever a DICOM talks to each other, they make use of queries. So like cecho, cfind, cstore, cmove. So these all kind of query. Echo is like whether the machine that I am talking to is present or not. It's like a ping request. Cfind whether when a doctor wants to find some information about the patient. Again, cstore if it wants to store something. Cmove if the information they want to move from one machine to another machine. So whenever there is a move happens, the machine has to be pre-configured with the IP addresses, port number, and AE title. So AE title is the application entity that I'll be telling you here. So DICOM attacking parameters. So the only three things that an attacker needs to attack DICOM system, DICOM images, or I would say the information about the patient. This first one is IP address, port number, and application entity title. So application entity title is like whenever any data coming. So how the PAC server will get to know that the image belongs to CT, MR, or ultrasound? So this AE title will tell that this machine is a CT machine. So AE title, application entity title, will be equals to CT or MR or US, that means ultrasound. So that is how the PAC server will get to know, or the another server to which the data is going, they will get to know, okay, this data belongs to this machine. Now DICOM attack, again, MITM, as I said to you, implementation of encryption certificates inside the hospital is very expensive, so you will not find much. PAC server flooding, as you know, PAC server receives the data, and storage is one of the problem in hospital as well. So whoever can provide more compression in the images, they will get the benefit in the market. How we will flood these servers, that I will show you in the demo. I will be making one rogue PAC server, and I will be sending fake information in that. Modification, again, if you can make the data, if you can make any modification in the data or the images that doctor is not able to understand, then again he has to go for the the X-ray or the MR. So again, it is exposure to the radiation, harmful radiation. No source check means whenever any information comes to PAC server, there again, these all attacks are based on the implementation. So I have never seen that any PAC server or any server checks for the authenticity of the source, or authentication of the machine from where it is coming, or authentication at the PAC server. So let me show you some demos, recorded demos that I have. So first I will be showing to you that as an attacker what information you need. That is, you need IP address, port number, and the AE title. So the demo I have prepared, it contains all the information. They are very long, 10 minutes, but I will be doing forward because I have written so that any person, because these will be shared so that you can understand it very easily. So information gathering one, yes. So let's first come to this one. So here I will be using 3 VMs. For the most left one is the this one will be the client that will be sending the DICOM information to the PAC server at the right hand side, and in between I am having one attacker. That is, if you see the third machine in between, that is the attacker machine. The most right one is the PAC server, and the left one is the any client that is sending the message. So if I directly go to that place where the data that I want to show you. Yes, so whenever any information from client to server goes, you can easily capture, and the information that you are looking at is here. So whenever there is any associate request with any PAC server, you can see the PAC's AE title. It shows that the called AE title means the machine you are calling. I am calling from the modality or the client machine to the PAC server, and it says the AE title for that one is the PAC AE title. So this is how you will identify, okay, so this is the PAC server in the hospital. If you see the calling modality AE title, the modality could be anything, CT, MR, or ultrasound. So from here, you can identify the source, destination, the port they are using to communicate, to transfer the file or to exchange the data, and the AE title. So these three things, one server checks when there is a communication with any DICOM server. So if you have this one, you can perform other kind of attacks like flooding the PAC server. So I will, because these can be customizable, so you need to know exact AE title. Now, based on this information, I can create my own server. I can I can perform the ARP spoofing kind of attack, and I'll make that server as a client or modality, and I'll send too many fake data to the PAC server. So it will again, it can garbage the real data, it can flood the PAC server that much level that it is not able to receive actual data. So this is the information that I want to show you. Now in second demo, that is how to flood the PAC server, that is MITM. So I'm just writing these things so that in a later, when you see the videos, you can understand which machine is what. So all the information I have written in this. Yes, so here I want to show you. So again, the left machine, if you see the behind one, that is the client, right one is again the PAC server, and middle is the attacker one. So from here, you will get to know the DICOM images. So it will, go ahead. Let me just. You can see the PAC details and all. The AE title, if you see calling AE title, here is city. That says the image that is coming from the modality is city. Let me forward a bit. Yeah. It says of both the system you have, create a rogue server. So here I am using PyNet DICOM, which is open source Python library that is available, and you can, if you want to perform any DICOM related checks, you can perform using it. So again here ARP spoofing I have done. Now we are going ahead. Here if you see, after ARP performing, if a client sends the information, it will go to the rogue server. Yeah. This is now attacker is sending the image to the PACS. You can see it successfully received the data that was transferred from the fake modality or fake or the attacker's machine. So this is how it could be done. So in DICOM, you just need three things: IP address, port, and AE title. I have one more demo. Let me show you. Oh, time up. Okay. So just give me 5 minutes. Do I have 5 minutes? Just 5 minutes. So I will be very fast. I'll be covering. You should have told me 10 minutes before. Okay, sorry. So I have one more demo that I will share with the team here, so you can have access to those. Just let it load. It's taking time. So meanwhile it is being loaded. So these are the DICOM attacks that I have shown you. Now the last part of this presentation is the how to pen test the medical hardened systems. So if you have seen the CT machine and MR machine, they will have one computer there which will take all the, which will fill up all the information and takes the X-ray or the ultrasound image, X-ray and ultrasound images. So these machines, when any, So these are hospital system. In the last two images, if you will see, they have the machine, they have two monitors, and in the on both the machines below, you can see the system. So these systems are generally very hardened. They will not allow any kind of access. You will never have file system access. When you open this system, you will only get access to the application login page where you need to log in and you need to perform the actions based on the user roles. Now these before you pen test these kind of devices, make sure you give enough amount to understand the application, because these applications are very big, very complex. You need to give enough amount. I am not saying one today, at least 1 week you need to understand the application, because it is very big and very complex, because they have to communicate from PAC server from different kind of modalities. So here you can see, let's take left hand side, you have ultrasound CT machine makes use of DICOM protocol. It goes to the workstation where it is being verified for the correctness of the images. Then it goes to the archive system, and archive system, from the archive system, the images are monitored by the doctor. So here the hardened system, just to let you understand, these are the two hardened system. One is the workstation, second is the doctor, based on the implementation if doctor wants to use it. But in general case, doctor don't want to get confused in the complexity. They more want to focus on the diagnosis part. So they don't want to have any complex system. So so the attacks, user roles, as I said to you earlier, user roles. Whenever you do any pen testing, as I said to you, it has multiple technician, nurse, doctors, one level doctor, second level doctor. Focus on this one, you will definitely find vulnerability. Now getting file system access, as I said to you earlier, you will only get access to the, only the application. You will not have the file system access. Monkey testing, how many of you know monkey testing? So monkey testing is just like pressing the key. That worked for me. I got full file system access just doing the monkey testing, because they will be able to forget the shortcut keys and something. You will directly get the file system access. Second is sticky keys. Anybody knows Windows sticky keys? Press 5 times and you will get access to it. Yep. Hyperlinks. Whenever you get any help page and all, go through the hyperlinks inside the help page. It will say save as or something. It will open up the file system. Save as functionality. If you have anything that goes to the hyperlink which says okay save as, if you do the save as, it will open up Notepad or something. From the drop down you can get access to the full file system. So these are the basic things that you can check before pen testing the while pen testing the medical devices. Look for writable directory. If you have writable directory, place your exploit based on if it is a startup, and you can get it reverse shell. Full understanding of the workflow of application. As I said to you, these are very complex. To get more logical vulnerability, you need to first understand the application very well. This is very important. Check for signing of executables, because these systems generally don't sign. So executables, you place DLL or any unsigned exe, that will be executed successfully. Command injection, based on my experience, command injection is the most common vulnerability that I have found in these hardened systems. So these hardened system doesn't have any pen drive access, most of the known shortcut keys are disabled, and you will not have any kind of thing. But if you have a small, small access like nurse access and all, you get into you in the user parameters. Just try command injection. My favorite vulnerability. There is no product in which I have not find this one. Again, sniffing hospital networks. If you are the data, the data that is moving here and there, that you can easily capture and see from these devices, because again, the implementation of these machines based on the hospital to hospital. Though the manufacturer provide the facility to support SSL and all, but because of the cost effectivity, that is, that is not implemented more. Yes. So again, securing, implement the encryption, data at rest, data in transit, authentication based on the certificate, user credentials. Anyhow, authorization should be properly implemented because it contains multiple user roles. Which information belongs to which user should be there. Upgradation. Medical devices are the legacy devices. Upgradation is the main problem. So they are very costly. Once they buy it, upgradation if not provided, then it creates a, it is eye-catching for an attacker. Software patching, old softwares are being used again, and there is no patching mechanism in the legacy systems. Most of the previous, I would not say right now, but the older medical devices contains, just 30 seconds, contains hard-coded secrets. And so if you are pen testing any hospital and all which is using more older version of devices, you will find this hard-coded secrets. So input validation should be there. As I said to you, command injection and injection kind of vulnerability are more. And my favorite one, mitigation, SSS tunneling. Cost effective, no cost involved, no port will be visible to the attacker. It's just 22 port, this side, that side. So more cost effective, more secure. This is my favorite, SSS tunneling. If they allow. Yes, thank you. If you have any questions, so you can shoot out or, yep. Okay, yeah. So you can, if you have any questions, you can contact me. Please.